Hello, hello. So, welcome to this blockchain introduction for the Near Certified Creative for the Creative DAO on Near Protocol. So, I am Fritz Wagner. I am your instructor today, this time. I have blockchain experience, yes, from developing some dApps and giving coach for entrepreneurs getting into this industry several years now here. So I hope I can help you to understand a little more about this. Let's start. So we might make these questions to ourselves when we are first introduced into blockchain, where Bitcoin is the first application. So who made this? There is a group of people probably called Satoshi Nakamoto, and how they basically invented this technology, blockchain, and patented this technology in 2008. And why they did this, which is the purpose? I believe it is to fix democracy because internet allow us to get all kind of information. So internet is the democratization of the information, and now Bitcoin allow us to democratize money. The economy can now have some set of rules that are made by the public. For example, the US dollar is not controlled by the people, not the government, but a private entity. They just printed, yeah, it's like having a money printing, but legally. They just printed like $10 trillion. They just duplicate the the whole mass of money on circulation. They duplicated it in less than 4 years, in the last 4 years, and basically making the money I had in save it on my under my couch is now worth less, and now I cannot buy the same stuff. I, it's inflation, make inflation. So it is just not fair because they make all the rules privately. So yeah, the first application for internet was the email, and now the first application for blockchain is money, Bitcoin, tokens. But of course, we have many more of that. You are here because you are creators, creative. Now we have NFTs and much more. There are more applications, but we have to start for the first one. That is Bitcoin. Yeah, it was registered in 2008, and the document was shared on Reddit, that is a social network. And 1 year later, the first exchange from US dollar with BTC was made. So now we know this is money. We can buy stuff with cryptocurrencies. So, well, happy to be here. Happy to be able to explain this. Thanks for listening. Now let's try to go with the first concept, data networks. If you miss some concept in all of this explanation, please feel free to reach me or look on Google. So we first had with this data networks construction, we had the client server. Basically, you have one computer that is in the center, receiving the connections from all of the other computers, and that is how Web 2 works. Web 2 services are like Facebook, Google, all the services you usually use. And the issue is that all the all of us as users, we are sharing information through one centralized server, and this centralized server owns our information. So if one person on Facebook wants to see our information, he's able to do that because he has access to the centralized server, and then he can use this information for his own benefit, like selling our data for government public campaigns for government elections. We can improve this, but how? It is not simple because peer-to-peer services need to be synchronized, and this is not easy. And they have to run um, in the with the same versions. I mean, they have to use the same language to understand between all of them, because there is no one centralized server to connect with all different computers who decentralized server could manage different languages. No, in this case, all of the computers need to be synchronized, and this is not easy, but it is done now. We have blockchain, so there is no center in this picture here. There is a hub or switch in the center. A hub or switch is not a computer saving information, but like cables connecting all of the other computers. So let's see more how this peer-to-peer connection works. How is a blockchain design? So blockchain design always has a consensus algorithm. The way these nodes, these computers interact each other need rules and procedures. There is a basic structure of blocks. So you are going to save information one by one. I mean, we are going to gather all the requests in a pool of requests, a pool of information with all the pending transaction. So we are receiving this information and we are going to check this. And each node, each different server connected to the blockchain, being part of the blockchain, are the blue ones here, are have all the information until date. So they are going to be able to check if everything is correct on this pending transaction. And after the checking process, they are going to save the new information in a new block. So basically, for Bitcoin, this information is an accounting book with all the information of each token holder. If I have tokens from 1 year ago, it is already recorded on this book. So if I am going to make a transaction today, in this book, nodes can check that I do own the money. How can I own this money? How they allow me to transfer the money? Because if I have the passphrase is basically the key to be able to the password to transfer these tokens. So yeah, the whole network, the blockchain, all of these nodes connected are a network system. There can be different types of nodes. For example, in NEAR we have the validators and others like the chunk only. Well, now in this picture, this is for Bitcoin. This is proof of work. Proof of work was invented in order to allow allow you to win from being part of the system. Like, it was made so everyone in the world can run the Bitcoin Core. Basically, by running this Bitcoin Core program in your laptop, you are being a node. You are saving all the information in your all the blocks in your laptop. That is like saving all the accountability book, and you are processing this transaction. So you should get a reward from the fees that are basically at the beginning was Bitcoin being printed, but this was hacked. I mean, the idea was that you prove that you have one computer by solving some questions. Like these questions was made so you can prove with your CPU that you have one computer, because you might try to be a bad actor, like running several times the Bitcoin Core on your computer, trying to make the network believe that you have several computers doing the work. But this cannot happen because you only have one CPU to prove to make the proof of work. So, but this system was hacked, and the ASIC miners were invented. That basically chips that only made to solve these questions. So connecting to a pool is one node. they make believe the network that they have an immense uh, capacity, that they are checking a lot of transactions, and this is not true. It's just one server. um, but yeah, that's basically one of the issues why this is not like these networks don't have scalability, and that's why now we have blockchains of third generation like Near, that do where we do have scalability, that we can process million of transactions, thousands or more, depending on how many servers we have running. But yeah, these pictures show how this all blockchain start. So there can be different types of nodes doing different works. I should remind that always, every time you make a transaction, this is like a message shared by broadcast. This means this message is sent to all the network, and each time a node receives a message, it replicates it doing the broadcast. So everyone is receiving all the transaction pool is full of everything that is pending, and yeah, everyone, all the nodes are synchronized. Well, let's do a recap because we are going fast. So how Bitcoin works is how blockchain works. So blockchain is a system, a networking system of many computers connected to each other through the internet, and all of those computers are running the same version of a program, and all of these computers has the same data storage in their in their hard drive. So all of them have this distributed information, and all of them run the same program, so all of them do basically the same. In the case of Near, we have the advantage of sharding and Nightshade. That's basically you separate the data, your database in different parts, and each node can focus their energy on one part of the database. So all this data is saved using blocks of information that again are distributed all over the network, and you go one by one. It's basically you save it information and then you save information again, and this was made in an exact date. It's like today I have one block, tomorrow I have another, or each second or each 5 minutes, depending of the blockchain. And it is decentralized because we don't have any center ruling the any other computer. Each computer runs the same version of a program, and if any of these computers do something different, it's basically leave it aside. It's not going to belong to us if these computers speak another language, if it is not doing the same as us. So again, with a transaction, remembering a transaction of tokens is the first application, but we have many more. If we request a transaction, this request is sent to the network in a broadcast mode to everyone. The network verifies, because all the different nodes are basically computers that can be your own laptop, who receive a pending request and verify in the accountability book that you own the money. So yeah, they can check that this money is going to be transferred to another wallet. So the transaction is recorded in a new information block, and this block is added to the chain. So we have a permanent record that no one can erase, because if you try to destroy the system, you will need to destroy all of the computers connected at the same time. And now basically the transaction is completed. There is a fee. Yes, we have to pay for the service. I mean, you have a client that is paid for processing this transaction. and all of these servers connected, the nodes, are the system. That, yeah, provides, all the system provides a service where you can upload a picture and you can prove that you own these pictures because it's owned by your wallet. This means like an NFT. And maybe this NFT, this picture, is also a smart contract that can allows you to use it into a game. So you have some features, special features when you use the game because you own this NFT. So yeah, there are many other implications on any any other industry like assurance. We can talk more about it in another occasion, but yeah, I will try it right now. If you have Oracle, our Oracle can be connected with a centralized server, uh, or different providers of information, but our Oracle is also connected to the blockchain, and he has all the information, for example, of flights, and you are connected into another blockchain and you are paying for assurance for flights, that if you lose the flight you are going to get a payment back. So a payment, yeah, to solve your situation. So as this smart contract is connected with the Oracle, he can receive the information. This contract knows when you miss the flight because I don't know, whatever happens, and the plane didn't get in time, and automatically can process the payment. So we can save all the trouble of contacting people from the assurance company. So yeah, that can be happen. But all of this information, who is processing it? Not one centralized server. Is not owned by a company, but this is running by a networking system of different computer where everyone has as the same role to process transactions, to process information. So yeah, no one can do something as individual, and this is also why Web3 projects are community driven. The community is very important in this ones. Sorry, I extended in that one. So we had proof of work, and now these days we have proof of stake. In the case of proof of work, this computer use different chips and electricity to make the network believe that they have an immense amount of power, that they are processing a lot of transactions, but that is not true. uh, it is not real. They are just doing the proof of work, but that doesn't mean they have a lot of servers checking transactions. In the case of proof of stake, it is directly related to providing the service. So it is more, in this case, proof of stake um, allows a server to get rewards, to get paid with fees by staking. This server just have to prove that several X amount of tokens is frozen for this server. There is a signature to froze these tokens in order to this server to prove that they are staking. So now you can invest from your wallet, but like it's really from your wallet. For example, in the new wallet, there is a staking feature, and you can stake into a server, but you are not really sending your tokens to that server. You are just frozen the tokens from your own wallet, so no one can take this away from you. When you um, invest, or yeah, like you have savings in a bank, inside a bank service, a traditional bank service, you have your savings there. If that bank go broke, you lose your money because your money is not really with you. But now with blockchain, you can have your money with you at any time just by having your passphrase, and you even can gets some rewards from the takings from the protocol itself. You are going to learn more about this if you want. Uh, we can talk more about this in the groups, in the chat groups. Let's keep focusing on this introduction. So, what is the hash function? This can be a little confusing, but it's basically a process on information. The hash function, you receive some information and you have to deliver a result. And in this case, on blockchain, it could be understand like you are receiving like a reply, and you have to guess the question. So you get a reply like blue, and your chips are trying several questions like what's the color of the table, what's the color of the sky, until the real question for that exact result is given, and all the network accepts that you um, get all the reward from the next block. So all the transactions are checked, and a new block is saved, and you get the rewards, the fees from those transactions. So again, what happened? Proof of work was invented, so you can prove that you have one computer and no one is cheating, like running several times the application on their laptop to make believe the network that they have several laptops. But yeah, this was like hacked, and now we have the ASICs, specific assemble computers made to only uh, just for a specific task, that is to answer to this proof of work. So this is a picture of a server, like a normal server providing, for example, when you connect with Facebook, all the information could be stored and processed on a server like this on the left. And a PC gamer, a PC for you to play games on the right, that could be also used for proof of work to for mining. But yeah, so the proof of work mining is basically related to make profit, not to verify transactions. The servers are the one to verify transactions, who have all the storage and can check that because they have all the accountable book. So in the case of proof of work, these servers are usually pools or servers from centralized exchange that they have to own their own server to improve the service they provide. But now we have proof of stake, so all the servers are really into the task of processing transactions. This is important now here. So if you own the keys, you own the money. So it is your wallet if you have the keys, if you have the passphrase. Then this passphrase unlock like the vault with your tokens that is on the blockchain. This vault is on the blockchain. These tokens, the blockchain knows they belong to you, and you can transfer them because you have the key, the passphrase. In the case of a wallet address provided by Binance, KuCoin, Uphold, or any other centralized exchange, this wallet address is not your wallet. It's the wallet from this provider. They have their own accountable book, centralized accountable book, that is run by their centralized services. These centralized services can be connected to the blockchain, yeah, but they for example, if you transfer tokens into a wallet address provided by Binance or KuCoin, your user, of course, you go to deposit, you see this address, you deposit. This address can receive money. You can see the transaction, check, approve it on the blockchain, but you cannot use it, you cannot see it because this server had not updated the information in the centralized database that shows on the screen on your user that you have your money. This cannot be updated, so the money arrived into Binance, but Binance is not showing it to you. And if Binance go to broke, or it's just like a traditional bank, if they go to broke, they go broke, maybe they don't give your funds back. But now we don't need that centralized services. We don't need Web2. We don't need banks. Now we can have our own back in our pocket, like in a paper wallet. That's all the information we need to save in order to be able to access funds that cannot be hacked, cannot be changed, because blockchain protect us from that. There is a decentralization discussion in the cryptocurrency community that if someone owns more than 51%, they can do an attack. They can do it, but why they will do that? I mean, they have so much skin in the game. If they change something for bad, it's not going to be good for them. And also, some stuff like Ethereum Classic or Bitcoin Cash. I don't know if you are familiar with those. You can look into it. Uh, those forks can happen. I mean, fork is to make a copy. You can make a copy of a blockchain. That's why Dogecoin exists. Dogecoin is a joke. These guys want to joke about Bitcoin, just copy paste Bitcoin with a little differences, but yeah, copy paste. And yeah, that could happen. You can copy paste Bitcoin, but who is going to give that value? Is the community, is the people who give value to the tokens. And it's just like US dollar. It's the people giving value to the US dollar because people use it, but there is no real backup. I mean, dollars have no backup. They are not even owned by any people or centralized government. US dollars are from a private entity, but we use them as, and from the use we give it value. So it's the people, and if someone wants to attack, everyone can just say, "Hey, we are not going to change our version," or "Yeah, we are going to change our version." It happened with Ethereum. It was attacked. DAO tooling, like in Near, we have AstroDAO, and you can have funds inside of an account, but those funds can only get out with several signatures from different individual wallets. But yeah, there can be books, and someone attack the first DAO on Ethereum and withdraw the money there, making believe that the application that he has several individual wallets, but just with one wallet created like thousands of signatures, and he withdraw the Ethereum tokens, millions of dollars. But everyone on the community say, hey, let's erase that block of data, of information. Let's fix the book of the application, and let's run again Ethereum, checking all the pending transactions. So they basically erase the hack, like go back to the past, like erase these blocks, erase it on, but everyone has to do it. So everyone agreed as a community, erase the blocks, fix the issue on the application, and run Ethereum game. So those guys who didn't erase these blocks and continue with the former, with the real Ethereum, some sort of speak, they are called now Ethereum Classic. So in Ethereum Classic, the hack did happen. Yeah, just to tell you more about that the decentralization discussion. the this this technology is really driven by communities. That's why this is more democratic. So the technology blockchain run protocols like Ethereum use the blockchain technology to run, and in top of Ethereum you can run also applications like Ethereum itself. The native token is an application. There can be many applications, smart contracts. So when you write a smart contract, is you sign that with your wallet and save the information in the network database, the blocks, and then you can run programs. And you can information input can be added, and then some contract execution can happen. Yeah, that basically that's it. It's information stored that can be used to run programs. That's it. 30 minutes. I hope you like it, and see you next time.